The National Electrical Code, or NEC, mandates specific requirements for emergency power systems in hospital operating rooms to ensure patient safety and continuous operation of critical equipment during power outages. The NEC requires two independent sources of emergency power. This requirement for dual emergency power sources stems from the need for redundancy. If one source fails, the other immediately takes over, preventing any disruption to vital medical procedures. Firstly, the Essential Electrical System, or EES, as defined by the NEC, provides power to critical areas and equipment within the hospital. The EES consists of three branches, namely the Life Safety Branch, the Critical Branch, and the Equipment Branch. Operating rooms receive power from both the life safety and critical branches to ensure continuous operation. Secondly, the Life Safety Branch supplies power to systems essential for patient and staff safety. This includes emergency lighting, fire detection and alarm systems, and communication systems. This branch ensures that even during a power outage, the hospital remains safe and orderly. Thirdly, the Critical Branch provides power to essential medical equipment and systems necessary for patient care. In operating rooms, this includes surgical lighting, anesthesia machines, patient monitoring equipment, and other life support systems. This branch is designed to maintain the continuity of critical medical procedures. The Equipment Branch powers non-essential equipment that supports hospital operations. While not directly related to patient safety, this branch helps maintain the overall functionality of the hospital during a power outage. Both emergency power sources must meet specific performance criteria outlined in the NEC. These include voltage regulation, frequency stability, and transfer time. Voltage regulation ensures that the voltage supplied to equipment remains within acceptable limits, preventing damage or malfunction. Frequency stability ensures that the frequency of the power supply remains constant, preventing disruptions to sensitive electronic equipment. Transfer time refers to the time it takes for the emergency power source to take over when a normal power supply fails. The NEC specifies maximum transfer times to minimize any interruption to critical equipment. The NEC Article 517 covers healthcare facilities. It outlines the specific requirements for electrical systems in hospitals, nursing homes, and other healthcare facilities. This article addresses issues such as wiring methods, grounding, and emergency power systems. The NEC 517.30 discusses essential electrical systems for healthcare facilities. This section provides detailed requirements for the design, installation, and testing of emergency power systems in hospitals. It covers the different branches of the essential electrical system and the equipment they serve. The NEC 517.30 C1 specifically addresses the sources of power for essential electrical systems. It requires that healthcare facilities have two independent sources of power to ensure continuous operation during power outages. This redundancy is critical for patient safety. The first source of power is typically the normal power supply from the utility company. This is the primary source of power for the hospital under normal operating conditions. The second source of power is an alternate power source, such as a generator or an uninterruptible power supply, or UPS. This source provides backup power in the event of a failure of the normal power supply. Generators are commonly used as alternate power sources in hospitals. They provide a reliable source of backup power and can operate for extended periods. Generators must be regularly tested and maintained to ensure they are ready to operate when needed. UPS systems provide a short-term backup power source. They are typically used to protect sensitive electronic equipment from power surges, voltage drops, and brief power outages. UPS systems can also provide power during the transfer to the generator. The NEC requires that the alternate power source be capable of supplying power to the essential electrical system within 10 seconds of a normal power failure. This rapid transfer ensures that critical equipment continues to operate without interruption. The NEC also requires that the essential electrical system be tested regularly to ensure it is functioning properly. These tests include load tests, transfer tests, and voltage regulation tests. Load tests verify that the system can supply the required amount of power to all connected equipment. Transfer tests verify that the alternate power source can take over when the normal power supply fails. Voltage regulation tests verify that the voltage supplied to equipment remains within acceptable limits. In addition to the NEC requirements, hospitals may also have to comply with other standards and regulations related to emergency power systems. These may include standards from organizations such as the Joint Commission, which accredits healthcare organizations. The Joint Commission has specific requirements for emergency power systems in hospitals. These requirements address issues such as testing, maintenance, and training. Hospitals must also comply with state and local regulations related to emergency power systems. These regulations may vary depending on the jurisdiction. To summarize, the NEC requires two separate and independent sources of emergency power for hospital operating rooms to ensure continuous power in critical areas. These sources must meet specific performance criteria and be regularly tested to ensure they are functioning properly. Compliance with the NEC and other applicable standards and regulations is essential for patient safety and the continuity of medical procedures. The first source is the normal power supply, and the second is an alternate source like a generator or a UPS. These systems are designed to keep the lights on and critical equipment running without interruption during a power outage. The electrical design of operating rooms involves careful planning and coordination to ensure safe and reliable power supply. Firstly, the design must comply with all applicable codes and standards, including the NEC and local regulations. Secondly, the design must take into account the specific needs of the operating room, such as the types of equipment used and the procedures performed. Thirdly, the design must provide for redundancy and backup power to ensure continuous operation during power outages. The installation of electrical systems in operating rooms must be performed by qualified and experienced electricians. The installation must comply with all applicable codes and standards and be inspected and tested to ensure it is safe and reliable. Proper grounding is essential for electrical safety in operating rooms. Grounding provides a path for fault current to flow back to the source, preventing electric shock hazards. The grounding system must be designed and installed in accordance with the NEC requirements. Isolated power systems are often used in operating rooms to reduce the risk of electric shock. An isolated power system is a type of electrical system that is designed to prevent ground faults. In an isolated power system, the power supply is not directly connected to ground. This means that if a person touches a live wire, there is no path for current to flow through their body to ground, reducing the risk of electric shock. Isolated power systems include a line isolation monitor, or LIM, which continuously monitors the impedance from each line of the isolated power system to ground. If the total impedance falls below a preset level, perhaps at 50,000 ohms, the LIM alarms, indicating that a ground fault may have occurred. The LIM does not interrupt power to the operating room. It merely provides a warning so the staff can take appropriate action. Regular maintenance and testing are essential for ensuring the continued safety and reliability of electrical systems in operating rooms. Maintenance should include routine inspections, cleaning, and testing of equipment. Testing should include load tests, transfer tests, and voltage regulation tests. All maintenance and testing should be documented and records kept for future reference. Training is essential for all personnel who work in operating rooms. Personnel should be trained on the proper use of electrical equipment, the hazards of electricity, and the procedures to follow in the event of an electrical emergency. Training should be provided on a regular basis and documented. The NEC also has requirements around surge protection within healthcare facilities. Surge protection devices, or SPD, are designed to protect electrical equipment from voltage spikes and surges. These devices divert excess voltage to ground, preventing damage to sensitive electronic equipment. The NEC requires SPD in specific locations within healthcare facilities, particularly where sensitive medical equipment is used. These SPD must meet specific performance standards to ensure effective protection. The location and type of SPD will vary based on the voltage, current, and sensitivity of the equipment being protected. The NEC also addresses the use of uninterruptible power supplies, or UPS systems, in healthcare facilities. UPS systems provide backup power to critical equipment during power outages. They typically consist of batteries, inverters, and control systems. UPS systems are commonly used to protect computers, patient monitoring equipment, and other sensitive electronic devices. The NEC requires that UPS systems meet specific performance standards and be regularly tested to ensure they are functioning properly. The size and capacity of the UPS system will depend on the power requirements of the equipment being protected and the desired runtime during a power outage. The NEC also addresses the use of generators in healthcare facilities. Generators provide a reliable source of backup power during extended power outages. They are typically powered by diesel fuel, natural gas, or propane. Generators must meet specific performance standards and be regularly tested and maintained to ensure they are ready to operate when needed. The NEC requires that generators be sized to meet the power requirements of the essential electrical system. The essential electrical system includes circuits that supply power to critical areas such as operating rooms, intensive care units, and emergency rooms. The NEC also addresses the use of automatic transfer switches, or ATS, in healthcare facilities. ATS automatically transfer power from the normal power source to the alternate power source in the event of a power outage. ATS must be designed and installed to ensure a smooth and reliable transfer of power. The NEC requires that ATS be tested regularly to ensure they are functioning properly. The transfer time of the ATS is critical for minimizing any interruption to critical equipment. The NEC provides guidelines for selecting the appropriate type and size of ATS for different applications. The NEC also addresses the use of emergency lighting in healthcare facilities. Emergency lighting provides illumination during power outages, allowing staff to safely navigate the facility and continue providing patient care. Emergency lighting systems typically consist of battery-powered lights, generators, or UPS systems. The NEC requires that emergency lighting be provided in all critical areas of the healthcare facility, including operating rooms, corridors, and stairwells. The NEC also specifies the minimum illumination levels required for emergency lighting. The NEC also addresses the use of fire alarm systems in healthcare facilities. Fire alarm systems detect fires and alert staff and patients to evacuate the building. Fire alarm systems typically consist of smoke detectors, heat detectors, manual pull stations, and audible alarms. The NEC requires that fire alarm systems be installed and maintained in accordance with the National Fire Alarm Code, NFPA 72. The NEC also specifies the requirements for the power supply to the fire alarm system. In conclusion, the NEC requires two separate sources of emergency power for hospital operating rooms to ensure continuous power in critical areas during power outages. These requirements are designed to protect patient safety and maintain the continuity of medical procedures. Compliance with the NEC and other applicable standards and regulations is essential for all healthcare facilities. These backup systems are not just about convenience, they are about preserving life when the main power grid fails. Hospitals, in particular operating rooms, require an uninterrupted power supply to ensure that medical procedures can continue safely. The complexity of hospital electrical systems requires detailed adherence to regulations like the National Electrical Code. The dual emergency power source mandate is a cornerstone of these regulations, ensuring patient safety during unforeseen events. Each component from generators to UPS systems has specific roles, testing protocols, and maintenance schedules. Furthermore, these measures collectively work to mitigate risks associated with power disruptions, making certain that essential medical equipment functions without failure. This approach underscores a hospital's commitment to patient care and safety during emergency situations.